Assalamualaikum. Here is a video from Group 4 with a project of portable bag holder. Here is the introduction. We have noticed that the problem of students to put their bag in the lecture hall, and we also noticed that in order to produce a portable bag holder, it should have a characteristic of a lightweight, have a higher strength, and long-lasting. And the objective of our project is first to produce a high-quality portable bag holder by using additive manufacturing process. And the second one, we want to analyze the process of additive manufacturing regarding the process parameter, which is the material, the build time, the strength, and the cost effective to produce a good portable bag holder. And the third one, we want to determine the most suitable process for produce the portable bag holder. So the scope of our project, we only implementing an additive technology, which is we only use the process of the 3D printing. And the second one, we analyze it by using a simulation software, which is the Ultimate Cura 4.6 software.
Assalamualaikum. I, Tuan Muhammad Mustaqimi bin Tuan Osman. I would like to present about lecture review. I only choose 5 examples. Okay, for first one is about meaning of additive manufacturing. I take article for Coy Kendall. It states that additive manufacturing can refer as a joint material process for making structure from 3D model data, topically layer after layer as a reverse subtractive manufacturing technique. For the second one is about AM process. For literature state, AM process focus on PBF include inspecting a metal powder coating mounted on a building site utilizing an extreme heat source such as laser or electron beam, which contribute to specific coating map. For the third one is about category additive manufacturing. For the Ala-Waldi, additive manufacturing was truly investigated for their ability to process ceramic or metal for processing a 3-dimension structure via layer by layer process. For the second last is FDM. It's about FDM. Okay, Ali Haidari state FDN is same which other method. FDN can fabricate from the small part until the large part depend of the dimension of machine from layer by layer until it produce the end use part. For the last one is about SLA or stereolithography machine. I take example from Yan. SLA is a one of 3D printing machine that process commonly used for development of high fidelity design and engineering product. Okay, I pass to my friend.
Assalamualaikum and good morning. Thank you to my friends for the previous chapter. For me, I will discuss more on the methodology, chapter 3. Okay, for the content, we have an 8 part, and for first one is the design of the product. As you can see, for the left is the STL files for the handlers, and the right one is the adhesive. Next one is the Katiab software, and the figures shows the orthographic projection drawing for the handler and the adhesive. After that, for the material selection and scoring table. For material selection, we're focusing on the density, tensile strength, thermal conductor, and melting point. And all the results can be seen at the final report. And for the right one is the scoring table. Also, we're focusing on density, tensile strength, thermal conductor, melting point, and the total all can be seen at the final report. Okay, for the cost estimation, we have 3 material, which is ABS, polymer resin, SLA, and PLA. And the first one is the 8 ringgit 6 cents until 9 ringgit 50 cents for per kilogram. And second is the 35 ringgit 37 cents per kilogram and 55 ringgit per kilogram. Okay, for the build time, for the faster one is the PLA and SLA, which is 13 minutes, and the slow one is the ABS for 15 minutes for adhesive. And handler for the slowest one is the 2 hours 40 minutes, and the faster one is the PLA 2 hours and 20 minutes. And all this can be seen at the Cura software. Okay, for the effect of machine setting to weight metric, FDI shows that it can produce lightweight, strong, and dimensionally stable part. Meanwhile, SLA with a stereolithography, scene height resolution bit, and larger section may be constructed up to 2 meters. For the chosen material, we focusing on the ABS filament because it the most 3D printing plastic that use, and after that it thermoplastic and contains an elastomer based on polybutadiene, make it elastic and shock resistant. Okay, the last one is the software. We use Ultimaker Cura. Why? Because it's the best for the simulation and it can shows the product layer by layer, and most importantly it's reliable for all the user to that want to see the simulation of product for additive manufacturing. That's all.
Next, result discussion part. Limitation of the semiotic part. First, general speed. The complexity of the model and the complexity of the process are directly proportional to the amount of time spent planning. The actual printing process of layered manufacturing is directly affected by how the model is sliced, oriented, and how the design space is filled. Printing speed affects strength of print part. Second, part orientation. Surface quality tends to be one of the more researched topics when looking at possible orientations. Layered processes can cause a staircasing effect on surface with curvature. This can be reduced by changing the orientation of the part to have certain angles parallel to the build orientation. Effect of material of the part. First, strength. From the first graph, it was clear how much stronger the tough resins are compared to the standard. Comparing tensile strength is a simple way to determine which material is stronger, and also it was clear that the resin were much tougher than the standard. Based on the second figure, the research found that tough resin, which is Siraya blue, was stronger than some FDM materials like ABS and ASA, tough not quite as strong as PLA and PEPG. Second, surface quality. SLA 3D printing produce highly detailed and accurate parts with very nice surface finish. At the same time, SLA is slowly being used for more diverse application because there is a greater variety of resin available. Still, when tough and functional parts are required, SLA printing is not usually the go-to technology. Effect of machine setting of the part. Build orientation. Fracture strength depends on the build orientation relative to the applied stress. Second, material setting. In FDM, polymers are commonly used for model prototyping and low performance material, but there is still a strong demand for polymers to be produced as advanced material. SLA is known for its fine features, smooth surface finish, ultimate part selection, and accuracy. Third, temperature control. Based on the graph, the pattern of how the temperature of the extrusion changes based on the pace of the print. Although that is not the factual statement, as it may differ depending on other criteria such as other parameters. Temperature control is important in additive machining since it will affect the speed. ABS and PLA are comparing since both of these materials are available in FDM and SLA processing machining. Suitable material and cost for both AM technologies in our project. First, SLA, photopolymer resin. Second, FDM, use ABS. Here is, we can see that cost of ABS is more cheaper per kilogram than photopolymer resin. So, for professionals who need the best possible surface finish and special material properties like dental or ceramic resin, there are more expensive material.
So, As a conclusion, a high-quality portable bag holder has been made up by using SLA technology with the lowest build time process. And the second one, we already studied the analysis of the process parameter during the 3D printing process. And the third one is the implementation of SLA technology as a suitable rapid prototyping to produce a portable bag holder by using a simulation software. So, it is recommended to do this analysis design and process practically to take count the external factor during the process. That's all from us. Thank you.